Hi Algebra 2, this is Miss Tate. We're going to be working on Note Set 3 today, so you can either print those off on Canvas or you can work it on your own paper. Remember, do write things down, that's how you learn things the best. Also, if I say pause the video, be sure to pause it, work through those problems, and then you can start the video back up to make sure you're doing things correctly. So here we are on Note Set 3, and this is reviewing all the things that we've been putting together over the course of the last couple of days. Once again, we're starting with a parent function. Remember, this is the most basic function of this family of absolute value functions. So let's go ahead and look at problem number 1A here. So we see that we're going to take absolute value, and these numbers do some operations or do some transformations to this parent function. If you remember back over the course of the last couple days, since this minus 2 is inside the function, it will change x's. Since this plus 3 is outside the function, it changes your y's. So how does it change those things? Well, do you remember what the quantity of x minus 2 does? It goes right 2. And then the plus 3 on the outside is going to take your graph and go up 3. All right, let's do that. So I'm going to go back to my parent function, and since we're working with absolute value, I like to start with this 0, 0 origin, the vertex point. So let's take the vertex and do exactly what we wrote down. I'm going to take this point and go over 2 and write 3. Now I'm going to stop there for just a moment and talk about, while we're going over 2, how does that change the x's? Well, algebraically, we're adding 2. And what about going up 3? Algebraically, how does that change the y values? You're adding there as well, just kind of a side note. Okay, let's keep going. So let's take the point 1, 1. We're going to go right 2, up 3. Let's take the point negative 1, 1. We're going to go right 2 and up 3. And I'm going to label those quickly. 3, 4, 2, 3, 1, 4. Do we have enough to get the shape of this graph? I believe we do. So let's make sure that this function follows what we said. Does it look like we have taken our parent function and gone right? Does it look like we've taken our parent function and gone up? So our last thing we need to do is write g of x as a function of f of x. So I'm actually going to come back up and do that right here. It doesn't really matter where you do it, but I'm going to do it here. So I want to take f, and I want to perform these transformations to f of x, So as a reminder, x minus 2 is inside the absolute value, so it's inside my function. So therefore, if I write this in function notation, I'll have f of x minus 2. And then this is saying add 3 to the function, and there we go. That's what that meant. Let's go to B part. All right, B part actually has 3 transformations going on. Here we see inside the function, so that means we have something changing our x's. Here is outside the function, and so that's going to change my y. And another outside the function, so that's going to change my y. Now the x is pretty easy. You could probably already go down and tell me, at the bottom, tell me that this needs to go left 3. But then the y's, we need to talk about the y's just a little bit, because it does matter which one of these I do first. It will matter. The graph's going to be wrong if you choose the wrong one first. So we've already mentioned today what this minus 2 might do. We mentioned it over here with this plus 3. So we know that that's going to go down 2. And algebraically, that means that we're going to take our y values and subtract them. If you look back at yesterday's notes you did live, you looked at what a negative does. And this negative on the outside is a reflection over the x-axis. I'm going to write rocks there. But algebraically, what are you doing to all your y values? Well, you're multiplying them by a -1, actually. So let's think about these two operations with y's and the order of operations. Do you multiply first or do you subtract first? Well, you learned that a long time ago. You multiply first. So when it comes time to describing these transformations, that is what must come first or your graph will be wrong. We must reflect over the x-axis first. And then we must go down 2. And remember, reflecting over your x is really multiplying y by a -1. That's what you're actually doing there. So let's go to this parent function and graph. So again, since this is absolute value, I start with 0, 0. I'm going to go left 3. Okay, so let me pull up so you can see this table. I'm going to go left 3. 1, 2, 3. I'm now going to reflect over the x or multiply my y by a -1. Since this is on the x-axis, this point will not change with that transformation. So I'm going to keep my pencil in the same place. And now I'm going to go down 2. 1, 2. All right, from my parent function, I'm going to take 1, 1, go left 3. 1, 2, 3. Reflect this over your x-axis. Another way to look at that, and that goes here, another way to look at it, though, would be to multiply your y by -1. So let me go back to where I was. The y value currently is 1. 1 times -1 is -1. Now I've got to go down 2. 1, 2. And let's take -1, 1. I'm going to go left 3. 1, 2, 3. Reflect it over my x-axis. So I was at +1. That puts me at -1. And then down 2. 1, 2. That's enough to get the shape. Let's double check. Has the graph gone left? Has it been reflected? And has it gone down? And I believe it does. And I'm going to practice some good skills here and label just a couple of points. Okay, so last, we've got to do this section, right? G of x as a function of x. And so I'm going to come back to the top for just a second, and that's where I'm going to do this. So inside f of x, I'm going to have x plus 2. That's what moves it left. I'm multiplying the y values by a negative, and then I'm subtracting 2. So that's what that part means. All right, let's turn the page and look at the back of the next page. Once again, we see a new parent function, a square root function. So let's take a look at a. We have nothing inside this function, so that means we have no left or right movement. 3 is on the outside. So my question is, are you multiplying or are you adding or subtracting? Well, you're multiplying. You're multiplying your function. You're multiplying your function by 3. So I'm going to write this 2 ways, actually. Let me write it here. Multiply y by 3. Now, to get the description, I have to think what this means. Is multiplying y vertical or horizontal? That's vertical. If I multiply by 3, are my numbers going to get bigger or smaller? They get bigger. So that's called a stretch by 3. Sometimes you'll see us abbreviate that as VS by 3. But the correct definition or the correct transformation is a vertical stretch by 3. So let's take our parent function. 0, 0 is on our parent function. If you take the y value of 0 and multiply it by 3, guess what? It doesn't change. On our parent function, I have the point 1, 1. The y value is 1. 1 times 3 is 3. That y value will change to 3. Notice I did not change the x. I now have the point 4, 2 on the parent function. It has a y value of 2. 2 times 3 is 6. So that point, the x doesn't change. the y is now 6, and I have enough to get the basic shape. Does it look like we took this graph and stretched it vertically by 3? Now let's write this in function notation. Well, that's pretty easy here. I'm just taking f of x and multiplying it by 3. Now, I would pause the video here and try B part and see what you can come up with. Hopefully you've had a chance to work this problem. So as I look at B part, I see that I have nothing inside the function. This 1/2 is on the outside and it's being multiplied. So notice I wrote you're multiplying y by 1/2. So let me ask you some questions. Y, is that vertical or horizontal? It's vertical. If you multiply by 1/2, does that make numbers bigger and they stretch, or smaller and they compress? They get smaller. So I came down already and wrote it's a vertical compression by 1/2. Another way you could abbreviate that, and no, you do not have to write both, one or the other, is VC by 1/2. So I'm going to take my parent function 0, 0. This has a y value of 0. It will not change. It stays the same. Let's take the point 1, 1. What's its current y value? Is 1. 1 times 1/2 is 1/2. That point is now 1 and 1/2. Notice the x didn't change, only the y did. Let's take the point 4, 2. Its y value is 2. 2 times 1/2 is 1. That point becomes 4. X didn't change. 1. And we have enough to get the shape. So notice we have a stretch and a compression both. I would take a couple of seconds, pause the video, see what you can do here putting things together. As we're looking at 3a, let's just talk about the transformations first. So we see that we have a quantity inside our function. Our original function is x squared. So inside our function is plus 1, which means we're going to go, that changes an x value. The -2 out front and this -2 are outside the function, so both of those are going to change your y values. So since we only have one x, I'm going to go down here and go ahead and say it's left 1. Now, we've already talked about order does matter. Which one will come first? Will I deal with this -2, or will I have to deal with this -2? So you think about what mathematical operation each of these are. The one that's out front of your function is multiplying by -2. This is subtracting -2. So you want to follow order of operations. We want to multiply by the negative and the 2 and subtract -2 in that order. So let's go here for just a second. I'm going to write this in parentheses because this isn't describing, but you're going to multiply by a -2, and then we're going to subtract 2. Now I bet you can tell me to subtract 2 is going to go down 2. So let's go back and talk about what multiplying by -2, how we describe that. Well, if we multiply our y's by a negative, think about it, we did that earlier. Remember? It's reflecting over your x. Then if we multiply by 2, since this is y's, it's vertical. Does multiplying by 2 make things bigger or smaller? Stretch by 2. So actually, this -2 out front has 2 transformations to it. It's a reflection over your x and a vertical stretch by 2. So I'm going to come up here and take 0, 0. I'm going to go left 1. Vertical stretch by 2, that doesn't change it. Reflect does not change it. Down 2. I'm going to take the point 1, 1. Go left 1. Multiply my y by -2. I'm at 1. 1 times -2 is -2. And then down 2. -1, 1's a parent on my a point on my parent function. I'm going to go left 1, multiply my y's by -2, I'll be at -2, and down 2. And here's my function. And really quickly, because I'm running out of time on this, I'm going to write this in function